You use the same procedures that you did before to solve a system of a 2 by 2, but we're going to use it to solve it for 3. What I mean is we're going to take one of these 3 equations, and you'll hear me use this term, we're going to use it as what's called a pivot to help eliminate variables in the other 2. So we're trying to find some way to get rid of one variable in both equations by using one of the equations. That makes sense. Here's what I mean. Looking at these here, do you guys all agree that if I took the top equation and I added it to the second equation, z's would go away? If I took the top equation and I added it to the bottom equation, would the z's go away as well? So what I'm doing here is I'm going to use this top equation to eliminate a variable in the subsequent other 2 equations. It could be the top one to eliminate the bottom 2. It could be any variance of that. Okay. Could I have used the y to get rid of it and done all that too? Yes. You can make any decision you want to eliminate something. It does not matter. Okay. So here's what we did. I'm going to write out that first equation. And I know I'm going to add it to that bottom equation. And I do it again. And x. Okay. I use that equation twice. I'm sure you may or may not have remembered when we did systems of equations with 2 variables. Remember how I drew those lines through them to separate the pieces? I still do that. For me, it's an organizational thing. If you do it, great. If you don't do it, it's no big deal. I like to do that just so that way I remember where my signs are. I'm just going to add them all together. All right. 2x plus 4x. Woo-hoo. Okay. Negative y plus y. 0. Z plus negative z. 4 plus 14. Well, that worked out nicely. What's x? 3. Okay. Hey, we're a third of the way done. Okay. Oh, tip. Remember how we had ordered pairs before? Like I said, we're going to have an ordered triple. Since we know what x is, write it down. Then we start knowing which ones you've got. Okay. Every once in a while, I have a decent idea. Doesn't happen very often, but it does happen. It's kind of remarkable. Okay. Do the same thing. All right, ready? 2 plus 1. 3. Negative 1 plus 3. That goes away. You get that. Huh. We know what x is. What? Oh. So since I know what x is, can I use that to find y? What's y? 3. Good. And then what do I do to find z? Yep. And I just do another substitution to find z then. Does it matter which of the 3 equations I choose? No. It does not matter. Ideally, I'm probably going to use the one that has z as a positive just because, I'm not being a positive person. Sorry. 6 minus 3 plus what is 4? And there's your answer. Eh? Are they always this quick and easy though? Now, and that's one thing that does show up, okay? If you start getting fractions like 73 over 11, you're probably on the wrong track. But if you get a half, okay. All right? So pay attention to what numbers you wind up with before you go crazy on things. All right? Now we're already doing this. Hey guys. One of the things that occurs a lot here, since there are so many numbers, so many variables, it's so easy to transpose one incorrect. So if you do start getting really god-awful numbers for fractions and stuff, 9 times out of 10, well, 8 times out of 10, you might have written down something wrong. The other 2 times, you just screwed something up. And then by something is probably a like 3 plus 2 is 6 as instead of 5. That's for this class. That's usually the simple arithmetic is what gets screwed up, not the procedures and how things work. In this one here, let's see, we got 5x minus 3y plus 5z is negative 1. 3x 2y plus 4z is 11. 2x minus y plus 3z is 4, not negative 4. Excuse me. So when you have this, which of the 3 do you want to use to eliminate something from the other 2? The bottom one. Yeah, that's what I'm thinking too. Why are you thinking the bottom one? Because the y is just a y. It's negative 1, but we can work with that. We can multiply it by some scalar to help eliminate y's and the others. Everybody see that? Do you have to do that method? No. Could you do other things? Sure. It's just messy. Okay. So I'm going to use the y value. I'm going to use this one to eliminate the y here. Well, what do I have to multiply that bottom one by? 3. So I'm going to multiply that bottom one by 3. So that's going to be 3 times the 2x minus y, excuse me. So we get 6x minus 3y plus 9z is 12. This is a great reminder in how to use the distributive property. You guys tend to forget to multiply that last term, so don't forget. Write down that first equation now below it, 5x minus 3y. Same coefficient, same sign, we have to subtract. Sorry. Who chose that seat? Should have figured that out right away. They're just standing your way. So split them. 4 subtraction problems. Yes, ma'am. You can, or if you multiply by a negative, it's still going to work. Either way is fine. I know that if I did that, I was looking ahead, seeing that I would have 6 minus 5. I was going to have 9 minus 5. I knew I could work with those being not too terrible. Okay. Same, if you have the same coefficient, same sign, you always subtract because negative 3 minus negative 3 is just 0. So you wind up with, what do we get? 2x minus 4z. I was making sure you're paying attention. Good job. And 13, I believe. Okay. That's my first 2 by 2. But I'll eliminate y again in the other one, the middle equation now. What am I going to multiply that third equation now by to get rid of y in the second equation? Just by 2. Multiply it by 2. So I write it out that I'm multiplied by 2. I get 4x minus 2y plus 6z is 8. Guys. Yep, I was looking at the minus as I was writing it. Thank you. I was looking at the minus as I did that. Yep. Sorry guys, there's a plus 4z. I missed that. We would have figured that out real quick in the next step. Write down the middle equation now, 3x, 2y. Yes, sir. Why aren't we? We're not subtracting on this one. Oh, the first one? Same coefficient, same sign. What's negative 3 minus negative 3? 0. Remember our rules. Our rules for solving systems. If you have the same coefficient, opposite signs, you add. If you have the same coefficient, same sign, you subtract. So here we're going to add, because I have a negative 2 and a positive 2. If I add those together, they eliminate. You could do that if you want, absolutely. You'll get the same thing. We're adding. Guys, enough. Come on. Adding those through. 7x plus 10z is 19. Now you're down to two equations with two variables. What? Yeah, now you have another system here, an easier one. Yeah, in this case, what are you going to do? You're going to do elimination or substitution? Use substitution. Because well, here's the reason. Since I'm working with these two equations now, since I'm working with those two, I can do a system equation, multiply and subtract, and do all that linear combination mumbo jumbo. Or just say that x is 13 minus 4z. When you have a variable that has a coefficient of 1, it's always pretty quick to use a substitution step. So you get 7 times the quantity, 13 minus 4z, plus 10z is 19. Multiply in, you get 91 minus 28. Almost there. 18z over here, and I believe subtract it over, you get 72. Z is a number, you're right, and it's an even number. It's 4. Hey, look, it's 4. And now, since you know z, what are you going to be able to find out? What x is, and since you have x and z, then you can find out. There you go. You have an ordered triple started. We know z is 4. All right, 13 minus 16 is negative 3. Very good. So x is negative 3. And then last, we go back up. What was it, negative 3 and 4 so far? So 3 times negative 3 plus 2y plus 4 times 4 is 11. Well, 16 minus 9 is how much? 7. 11 subtract 7 is? It's 4. Man, you guys are quick today. Y is? 2. Hey, you figured that one on your own. Way to go. pain in the butt, isn't it? All right, all right. So speaking of being a big giant pain in the butt, think about how you solve equations. When you solve an equation, you're working backwards, correct? You're using inverse properties. Inverse of adding is, inverse of division is, all right? What's the inverse of square rooting? Squaring. There you go. Now, last year you guys did this. You did something like that. On the calculator, you had to hit a button to find the angles. Remember what button you were using? You're not using sine, the inverse sign. The inverse sign, you did this. Inverse sine of some decimal, and it gave you theta. That -1 symbol stands for an inverse. Okay? Now, look at the calculator real quick. You should see somewhere along there an x to the -1. You see that? That means inverse. Okay? So if you inverse a number, you basically are using reciprocal functions for it. For example, if I just do the inverse of 2, what do you think that is? I think you're wrong, but I bet it's a half. Anything to the -1 power is an inverse. You inverse it. I'm sorry, I shouldn't have been that mean about it. You know, it's Murphy, it's what I do, so. Inverse, it flips, it undoes stuff. It is. I'm getting there. I'm getting there. So, back to this. back to this problem we did here a second ago. See if you can follow where I'm getting these numbers from. You ever seen those before? What are they? Okay, they're brackets. Now, as I'm filling it in, what did I fill that with? Numbers. More specifically, where did I get those numbers from? From the equations, right? When the numbers are in front of variables, what are those called? Coefficients. Very good. Now, for giggles, what would I put for that? If there's no y value, what's its coefficient? 0. So if there's no y value, this would have become a 0. It just holds its place, right? Okay. Now, still there. When you take these brackets and you put numbers into them, it's called a matrix. Matrices are the plural. A matrix is another way of solving systems of equations. There are many, many rules and regulations and things and stuff that you have to do to figure out how these work. But it's the grand scheme of things, there's a button. Now, what I want you to think of here is this. What are the 3 variables that we're working with? X, Y, and Z. So what's happening here is that we're going to take a matrix, and then it has to equal what? What are the 3 numbers it has to equal? So we have to figure out a way to undo multiplying. What's the inverse operation of multiplying? Dividing or multiply by its reciprocal. The -1 power creates a reciprocal. So if we figure out a way to do this in the calculator, we know then, let me move this up, that if I have x, y, and z, this is where it gets important. It's going to equal our coefficient matrix. Gotta put this one first. To the inverse times direction do you row a boat? Left and right, correct? Horizontally. Hopefully you're rowing a boat horizontally, because if you row a boat vertically, you're dead. You went over a waterfall and you're dead. Okay? So, on your calculator, as with many other buttons on here, there are some shortcut keys. Alpha, zoom. Okay? Alpha, zoom. And it comes up with row, column. What you want to do is we're going to make a 3x3. I have 3 rows. I need to make 3 columns. Okay? And click OK. Up and down. Use your arrow up and down. And what's nice is that if you screw up rows and columns and you know what it's supposed to look like, if it doesn't look like that, you know you done goofed and you just fix it. Okay? So now what I'm going to do is I'm going to fill in that all those coefficients into this. All right, so it was 5 right arrow, -3 right arrow, 5 right arrow, 3. See how it automatically jumps down to the next line for you? It does it for you. It's a nice machine. Make sure you hit the negative button, not the minus button when you do those, otherwise you'll get an error. Okay? Now, like I was saying earlier, we're undoing this multiplying. And undo it, you use the inverse operation. The inverse operation is at -1 because the inverse of 2 is 1/2. Okay? So I get the inverse. And then I have to multiply it to what's called my solutions column matrix. So I have to create another matrix. 3 rows, 1 column. Alpha, zoom. Three rows, 1 column. Again, if it shows up 3 across, like 3 in a row, that means you just flipped it. You need to go back and edit it. And then fill in the blanks. What was it? -1, 11, and 4. Thank you. -1, 11, 4. Guess what you do now? Is that what we got for X, Y, and Z? Why? And that's okay. Because, what's that? No, go ahead, say it. Please, do it. If you want to say it, somebody else is thinking it too. Say it. Yeah, it is. It's always important. All right, here's the deal. First hour kept asking me, so what you're saying is I can use my calculator. Well, yeah, duh. Unless I tell you to not use your calculator. Why would I put this on a test? Just to see if you know how to press buttons, right? But if you think about what's coming up in the next couple of weeks here, we got PSAT, PACT, stuff like that a lot of people are taking. Systems of equations are in there. Don't do these by hand, guys. There's no point to it.
Wait, can you use this type on?
Yeah. That's why I'm teaching you guys how to use the calculator. Now remember, hey guys, remember, there's going to be a time that I'm not going to let you use the calculator in class. Right. Yes, sir. There'll be times when you guys get to your SATs, your ACTs, things like that. These calculators are legal, guys. Use a matrix to solve equations, man. It's so much easier. If it's a 2x2, it's multiple choice. Don't do the math. You just substitute, find the right answer. Don't math it. Yes, sir. Right. You work smarter, not harder. I do too, but it makes sense. And you guys gotta let go of some of it. The calculator will get you through a lot of it. Yes, sir. Oh God, no. Did I say that too fast? No, we don't do altitude doesn't do math testing. Right now, I think it's just the freshmen that are doing that. We're in algebra 1 class. Yes, sir. There's a PSAT coming up, I think, in October. I don't know. All juniors take it. Yeah. Otherwise, I know that there's practice tests you can take online and whatnot. But guys, what I'm getting at here with these things is, yes, there will be a time and a place for calculator usage. For example, for the rest of this week, after tomorrow and stuff, we're going to be getting into parabolas. Graphing parabolas. Yeah, I'll have you graph some of those by hand, have you do some of that stuff. And it's one of those things that'll be like the first bunch of tests that we take, our first quiz on this stuff next week. It won't be with the graphing calculator because the graphing calculator does all of the work. I need to make sure you can do the work before I allow you to use the calculator, okay? Plus, the other thing is when we get to the second half of next week, we go into the quadratic word problems, which means we have to know how to use the calculator to interpret graphs and functions and things like that. So as you get into ACT, SAT stuff, you're going to know how to search and find intersections. You'll learn how to find zeros, things like that. What is a maximum value? What does it mean to be a vertex? You're going to figure all that out by pressing some buttons. All right? So tonight, what I had you guys doing, I'm trying to pull it up. I believe, I forgot what page it was. Oh, here it is. I had you guys doing 5 of these. Now, of the 5, I want you to do one by hand. I don't care which one. I don't care which one. All right. The other 4, just write out in terms of matrices. Okay. When you're pulling up those values, you're looking at it on the problem. Create your coefficient matrix. Write it to the inverse, and then next to that you would put its column matrix for the solution. And those will be the order in which they get solved. X, Y, Z. I don't think this one. Yeah, that was X, Y, Z. Sometimes you'll see R, S, and T. Same idea. They go alphabetical. They solve them systematically. What the matrix C is doing when you use these inverse functions is that it's calculating what's called a determinant, and then after it calculates a determinant, it's multiplying it in. As it does that, it's finding what's called a an identity matrix. I forgot what it was. It's finding an identity matrix, which basically is ones on the diagonal. That means your value of x equals something, value of y equals something, value of z equals something. We do not teach matrices anymore. We haven't for about 5 or 6 years because there's a but. There's no reason. Unless you're going to be a math major, you don't need to know how to do matrices by hand. Bless you. Then you don't have to worry about doing it. What's that? All right, go ahead and get started on those. I got a book up here if you want to use it.